Hi, I am Sarmad. I recently graduated from the PhD program in Department of Electronic Engineering at the Gebze Teknik Üniversitesi, where I successfully completed my PhD under the supervision of Prof. Doktora Koray and Associate Prof. Doktora Abdullah. I will now be presenting my thesis in short and concise manner. My thesis title is Deep Domain Adaptation for the Semantic Segmentation of Remote Sensing Images. As we know, the semantic segmentation or pixel-wise classification play a crucial role in remote sensing image analysis and learning. However, achieving high performance requires a large amount of label data, which is often unavailable due to the time and cost involving remote sensing context. Possible solution is to use semi-supervised or unsupervised semantic segmentation. However, this method assumes that the training and testing dataset comes from the same coverage area. So what happens if we train the model with one coverage area and then test it with a different geographical area? So this is called domain shift. So to solve this problem, actually there's one concept called unsupervised domain adaptation, where the semantic segmentation leverages the information from the source image using the training data, and then we will test our model using a label target that set. To address this issue, actually, unsupervised domain adaptation aims to leverage the labeled source images and deploy them to unlabeled target images. One of the proposed method in this thesis is actually called unsupervised domain adaptation via short image-to-image translation. Actually, this proposed method consists of the synthesizing target images, target style source images that can then be used to train the semantic segmentation network via source domain label. The method's novelty actually lies on the design of image-to-image translation, as we see here, which is just content of the take the all source images with one target images. So this is called one shoot. And then we use the encoder to find the latent space. After that, we separate it to two parts. Then we take the content of the source image with the style of the target image to find the target style image. Then this image will contain the content of the take the content of the source image with the style of the target one. Here is the sum loss function of this method. Actually, the previous method contained from some disadvantage, whereas two separated steps of process use it, image-to-image translation, then semantic segmentation. So this is not end-to-end, and only just one level of alignment will be used. And also the previous method is generating method. So to solve this problem, actually, we try to use the Fourier-based image-to-image translation, where the two images, source and target, convert to the phase and amplitude, and then we'll take the low frequencies of the target image and then copy it to the source one to find the target style images. Actually, using this concept, we use four proposed method. One of the methods simple, just use Fourier transform, where we use the also class level feature alignment. Whereas after finding the target style image, we use two level of semantic segmentation, whereas the feature space and class information will be inputted to the final grain domain discriminator. So this is the first proposed method. A second proposed method, instead of using one beta value to find the boundary box of the copied low-level amplitude from target source, we use different beta value for each classes using by helping of the ground truth of the source one to find the target's style images. And then we also added a different level of the semantic segmentation using DeepLab version 3+. And take the final grain domain discriminator with two level of final grain domain discriminator, source with the target and target image with the target image. Then instead of using all images from the target image, also we propose a view shoot target images by using one image for each classes, and this is the output of the style images. And finally, also we proposed, instead of using Fourier transform, we use standard image-to-image translation called dual GAN, and then we just try to find the profile of the proposed method in the second level. Here we will not show all the computational tables. We just try to show this computational templates. As we see here, for the first method, the cost in the training times and the number of parameters. Our methods take lower than all of the methods and take the low number of parameters. Here is some feature maps of the previous method. As we see here, we just get high boundary region compared to the proposed method. The same thing for the later method using the Fourier transform. And this is the scientific outcome comes from the thesis during